Hello, this is FASTECH. Today, I will introduce Ezi-SPEED EtherCAT, a BLDC motor speed control system compatible with EtherCAT. First, let us explain the model designation of the Ezi-SPEED EtherCAT. Taking an example model name, in Ezi-SPEED EC, speed indicates a BLDC speed control system, and EC means the product supports EtherCAT communication. 60 refers to the motor flange size of 61 mm. Motors are available in sizes ranging from 61 mm up to 104.5 mm. H indicates that the motor output shaft has a geared type suitable for coupling with a gearbox. Depending on whether a gearbox is used, the shaft type can be selected. S for standard, without gearbox, and H for gearbox coupling. 30 represents the output power of both the drive and motor as 30 watt. The output corresponds to the motor size in ascending order: 61 mm 30 watt, 81 mm 60 watt, 90 mm 120 watt, 104.5 mm 200 watt and 400 watt. C indicates that the power supply voltage is AC 200 to 240 volt, either single phase or three phase. R5 means the gearbox ratio is 1 to 5. Gear ratios are available from 1 to 5 up to 1 to 200, as shown in the table. P indicates that a parallel shaft gearbox is installed. Gearbox options include a parallel shaft type and a hollow shaft flat type. Now, let us introduce the key features of Ezi-SPEED EtherCAT. Ezi-SPEED EtherCAT is a BLDC motor speed control system compatible with EtherCAT communication. It is a BLDC motor speed control system that supports EtherCAT, a high-speed Ethernet-based fieldbus. The system supports the COECAN Open over EtherCAT protocol, and operates in the velocity control mode, as defined in the CIA 402 drive profile. Additionally, it offers an I/O map mode operation based on drive data. Ezi-SPEED utilizes compact, lightweight, high output, and high efficiency brushless motors. Conventional DC motors use brushes and a commutator for rotation, requiring regular maintenance. In contrast, BLDC motors operate without mechanical contacts, utilizing a semiconductor-based drive circuit for rotation. This results in a longer lifespan and exceptional maintenance efficiency. The rotor incorporates built-in permanent magnets to enhance efficiency. Additionally, the system automatically controls motor current, ensuring a consistent torque characteristic across all speed ranges. Furthermore, Hall IC-based feedback control enables precise speed regulation from low to high speeds according to the command input. As an example, we will demonstrate motor operation using the BLDC EtherCAT master. The left motor operates in velocity mode as defined in the CIA 402 drive profile of the EtherCAT master. The right motor is set to I/O map command mode, demonstrating motor operation controlled via an I/O switch. Additionally, Ezi-SPEED EtherCAT offers three control interfaces: EtherCAT network control, I/O control and PC support software via USB connection. First, I/O control allows users to configure an operation system by connecting an external switch or PLC via an I/O input-output cable. Users can assign necessary functions to inputs and outputs, enabling up to 16 speed operation, emergency stop, and torque limitation. Additionally, it supports analog speed setting functionality. Next, network control using EtherCAT enables drive control by connecting to a master device such as an EtherCAT-compatible PLC or PC. Lastly, PC support software is available for easy and fast parameter configuration and operation testing of the drive. Let's take a closer look at I/O control. Ezi-SPEED supports 7 input channels and 2 output channels, allowing flexible control. Additionally, it supports analog control using either a variable resistor or an external voltage source. Users can assign various functions to the 7 input and 2 output signals, enabling control over motor start-stop, rotation direction change, torque limit release, and multi-speed operation. The system provides 16 sets of operational data, consisting of rotation speed, torque, acceleration time, and deceleration time, allowing for up to 16 speed operation. Parameters and operational data can be easily configured via PC support software. Additionally, an external variable resistor allows for continuous analog speed or torque adjustment. Users can configure offset and maximum values via parameters to fine-tune control precision. As an example of I/O control functionality, we will demonstrate an 8-speed control using switches as I/O inputs. The 3 yellow switches are assigned to P0, P1, and P2 functions. By toggling these switches on and off, users can select from 8 different operational datasets. If P3 is also utilized, the system can support up to 16 operational datasets. Additionally, motor speed can be controlled via an analog input using a volume knob. Ezi-SPEED adopts a compact, high-efficiency brushless motor, offering a small form factor while delivering high torque. For example, when comparing motors of the same output 60W, Ezi-SPEED has a compact 42 mm size, whereas an AC induction motor is 130 mm, making it significantly larger. In terms of weight, Ezi-SPEED weighs only 0.8 kg, compared to 3 kg for an AC induction motor, making Ezi-SPEED much lighter. Additionally, many AC induction motors include a rear-mounted cooling fan, which further increases their size, up to 3 times larger than Ezi-SPEED. Thus, using Ezi-SPEED enables compact equipment design. Despite its small size, Ezi-SPEED delivers higher torque than an AC induction motor. AC induction motors experience torque loss at low speeds, whereas Ezi-SPEED, leveraging BLDC motor characteristics, maintains consistent high torque across both low and high speeds. We will illustrate this further with a torque graph in the following section. Brushless motors utilize permanent magnets, which suppress secondary losses in the rotor, resulting in high energy efficiency. When replacing an AC induction motor with an Ezi-SPEED series motor, users can achieve lower motor temperatures, approximately 23% reduction in power consumption. Ezi-SPEED products offer a wide speed control range. Additionally, they utilize a proprietary vector control technique to ensure high-speed stability in motor operation. Ezi-SPEED offers a wide speed control range from 50 rpm to 4000 rpm, maintaining consistently high torque across all speeds. In contrast, AC induction motors combined with inverters typically operate within a range of 200 rpm to 2400 rpm, depending on the manufacturer. This results in limitations at high speeds and torque reduction at low speeds, making precise control difficult compared to Ezi-SPEED. Since Ezi-SPEED's maximum speed is more than twice that of AC induction motors, it allows for the application of higher reduction ratio gearboxes, enabling greater torque output within the same speed range. As an example, we will demonstrate stable speed control over a wide range using 2 drives. You will observe that both drives operate smoothly and reliably, even at their maximum speed of 4000 rpm and minimum speed of 50 rpm. Ezi-SPEED utilizes a proprietary vector control technique to ensure high-speed stability in motor operation. This vector control method, known as FOC field-oriented control, regulates the rotation of the stator's magnetic field through current control. By precisely controlling the magnitude and direction of the magnetic field, this method enhances torque and speed stability compared to traditional control techniques. As a result, Ezi-SPEED achieves a high-speed stability with a speed fluctuation rate of plus or minus 0.2%. Ezi-SPEED provides both torque limit functionality and load holding capability. The torque limit function restricts the current flowing through the motor, ensuring that the generated torque does not exceed the user-defined value. A 100% setting corresponds to the rated torque, and the limit can be adjusted between 0% and 200%. This prevents excessive force from being applied beyond what is necessary. For example, setting the torque limit slightly above the required load torque helps prevent excessive motor torque, reducing the risk of operator injury. This feature is particularly useful for speed control applications such as rollers, conveyors, and agitators. The torque limit function can also be configured using analog input. In this demonstration, we will use a volume knob to adjust the torque limit value. Since the torque limit function restricts the motor current, preventing the torque from exceeding the set value. If an external force greater than the torque limit is applied, the motor will not operate. Increasing the torque limit above the external force allows the motor to overcome the resistance and resume operation. The load holding function maintains the motor's position even when stopped by applying an appropriate holding torque. When an external force is applied while the motor is stopped, it generates counteracting torque to maintain its position. This allows it to function as an electronic holding brake, eliminating the need for a mechanical brake. For example, in a conveyor system that frequently stops and starts, the load holding function helps prevent workpieces from shifting or shaking when operations are paused. Unlike mechanical brakes, this function requires no maintenance, as it has no wear components, contributing to space savings and weight reduction. Next, we will demonstrate position holding using the load holding function. In this demo, you will see how the motor, when in a stopped state, generates counteracting torque to maintain its position when an external force is applied. This showcases how the load holding function acts as an electronic holding brake, effectively maintaining position without requiring a mechanical brake. Finally, with the support software provided by FASTECH, users can easily configure product parameters and perform operation tests. The drive and PC can be conveniently connected via a USB port for seamless setup and monitoring. FASTECH's support software offers a variety of functional features. Key features include operation testing, drive and I/O status monitoring, alarm monitoring, operation data management, and user parameter configuration. The operation testing function allows users to easily test motor performance by entering values for operating speed, torque limit, acceleration time, and deceleration time. This enables a simple and efficient way to control and verify motor operation. The monitoring function allows real-time tracking of drive and I/O status, as well as alarm history. Users can easily check current rotation speed, load factor, input signals, and alarm records. This provides a comprehensive overview of system performance and status. The operation data setting function allows users to configure 16 sets of operation data, including rotation speed, torque limit, acceleration time, and deceleration time. In the user parameter settings, all parameters can be easily and quickly adjusted. Additionally, configured values can be saved as a parameter file, enabling fast duplication across multiple drives. I will demonstrate how to easily operate various functions using the support software on a PC. As you can see, you can connect the drive's USB port to the PC using a USB 2.0 mini Type B cable. I will now demonstrate motor operation using the motion test function. With the drive I/O status function, you can monitor the drive, motor, and input-output signals. This concludes the product introduction for Ezi-SPEED EtherCAT, an EtherCAT-compatible BLDC motor speed control system. You can find product-related downloads such as catalogs, manuals, and drawings, as well as demo videos and webinar recordings on the FASTECH website. Thank you for watching.